Good evening to all. I am Subramaniam, working as assistant professor in automobile engineering at SNS College of Technology. So far, in the sessions we have seen about the manufacturing of the different parts. Now we see about the heat treatment and finishing of the gear process. So heat treatment and finishing of the are critical process in the gear manufacturing that enhance the mechanical properties, dimensional accuracy, and surface finish of the gears. The steps ensures the gear perform reliably under various operating conditions. The heat treatment of the gears is used to alter the physical and mechanical properties of the gear material, typically to increase the hardness, strength, and wear resistance. The common heat treatment process for the gears include carburizing, nitriding, quenching and tempering, induction hardening, and finally we see for the finishing of the gears. So in the heat treatment process there are four processes there. First is in each process we see about the process, purpose, and application itself. So the first process of the heat treatment is carburizing. Carburizing involves the introducing carbon into the surface layer of the low carbon steel gear by heating it into the carbon rich environment. So this process operates a hard wear resistant surface layer while maintaining a tough and ductile core. This after carburizing, the carburizing gears are often used for gears that need a hard surface to resist wear and a tough core to absorb the impact, such as automotive transmission gears. The next process of heat treatment process is the nitriding. So, nitriding process involves introducing nitrogen into the surface of the gear instead of the carbon by heating it in a nitrogen rich environment. This creates a hard and wear resistant surface layer without the need for quenching and resulting in minimal distortion. The nitride gears are used for the high surface hardness and fatigue resistance like aerospace gears. The third process of the heat treatment is quenching and tempering. Gears are heated to a high temperature and then rapidly cooled, quenched in water, oil, or air. After quenching, the gears are tempered by reheating to a lower temperature and then cooling it again. So, quenching increases hardness while tempering reduces the brittleness and improves the toughness. The process of quenching and tempering gears that need a balance of hardness and toughness, such as heavy machinery gears. And next, finally comes the induction hardening. Induction hardening involves the heating of the gear's surface layers only, not the full gear. Only surface of the gears has been heated using the induction coils and then quenching it rapidly. This creates a hard surface layer only with minimal distortion. So, induction hardening is suitable for gears that require localized hardening, such as those used in automotive applications only. And so far, you've seen about the heat treatment process. Now, you see about the finishing of the gears. So, finishing of the gears include the process of grinding, honing, lapping, short peening, and super finishing process. So, the five processes of the gear finishing process. So, grinding involves rotating the abrasive wheels to remove the small amounts of material from the gear surface. So, grinding itself. It improves surface finish, but we can see the gears can be finished in any one of the processes, any one of the five processes. It is not necessary to go for all the five processes. So, grinding involves the rotating of the abrasive wheels. It improves surface finish, ensures the precise tooth profile, and corrects any distortions from the heat treatment. Grinding commonly used for the high precision gears in automotive, aerospace, and industrial machinery. Whereas honing uses the abrasive stones or sticks to remove the materials and improve the surface finish. whereas lapping process involves the rubbing of the gear surface against a lap tool to achieve the fine surface finish. Whereas shot peening involves the bombarding the gear surface with a small spherical media shots into induce the compressor reduced stresses. And super finishing uses the fine abrasive films or stones to produce the ultra smooth surface finish. And thanks for watching this video. We'll see you in the next session.